Hi, welcome to our pre-calculus. The topic today is finding solutions in an interval for a trigonometric equation involving an angle multiplied by a constant. So very similar to the previous lecture, except that one was for sine and cosine. Here we have equation involving, say, cotangent or, sorry, secant and cosecant, and of course tangent also could be included. So we proceed as before. We take the interior argument, replace it by theta to start. At the end, we have to make sure we choose our k so that the angle is between 0 and 2 pi. So let's get started. First, we set theta to be the interior argument. So now I have radical 3 cotangent of theta plus 1 equal to 0. So that means cotangent of theta is minus 1 over radical 3. Next, we apply reciprocal identities. So that means 1 over tangent of theta is minus 1 over radical 3. Next, we flip both sides, so I have tangent of theta is equal to minus radical 3. So we simplify to basic equation. Now we can look up the table or the circle, unit circle, or practice drawing the unit circle and remind ourselves that way. So here I have a unit circle. Remember, this was the cosine axis, this was the sine axis, and this was the tangent axis. Minus radical 3 in tangent on tangent axis, say it is here. We connect to the origin and go to the other side. We see two angles, however you want to label them, that's fine. Here's one of the angles. You can go in the negative direction if you wish, or you can go in this direction. This angle is pi third, and we can use that to remind ourselves what the solution will be. So theta, that small angle, is going to be 2 pi third, and the larger angle is going to be 5 pi third. Now the complete solution is going to involve these two added to 2k pi. You can reduce your work by noticing that the difference between these two is just pi. So a slightly shorter way of writing the same thing is to take this small angle, 2 pi third, and then add k pi to it. So k pi, if I add 1 pi added to it, it's going to be my 5 pi third. And then additional multiples of pi is going to produce all the solutions that you had in these two places. So this is preferred. However, if you do it that way, it's also correct. Next, we say theta was 2x over 3. So 2x over 3 is equal to 2 pi third plus k pi. To solve, I take my equation and multiply by 3 halves to cancel 2/3 on this side. So x becomes pi plus 3 halves of k pi. Okay, next challenge is, well, which one of these answers are between 0 and 2 pi? If my k is 0, of course that answer is in the range that we want. Now if I add anything to it, like 3 halves of a pi, I'm going to increase the range of 2 pi. If I take k equal to minus 1 and subtract 3 pi over 2, I'm going to be at minus pi over 2. So the only solution that survives this whole process is x equals to pi. Next, we have an example with secant. So we have here, so let's take theta to be 2x over 3. So I have secant of theta equal to, take radical 2 to the other side, minus radical 2. I remember secant is 1 over cosine, so 1 over cosine is minus radical 2. I find the reciprocal of both sides, so it becomes cosine of theta is minus 1 over radical 2. If you wish to rationalize it, so multiply by radical 2 becomes minus radical 2 over 2. Now again, basic equation, you can look it up in the table, you can look at your unit circle or draw the unit circle. So I draw the unit circle. Cosine, remember cosine is here, minus radical 2 over 2, and we draw a vertical line there. So the two angles that we get, familiar angles to us, are these two angles. So theta is either 3 pi over 4 or 5 pi over 4. Next, we say that, well, what are all the possible solutions? All possible solutions, so theta 3 pi over 4 plus 2k pi, or 5 pi over 4 plus 2k pi. Next, we go after x. So this means 2x over 3 is 3 pi over 4 plus 2k pi. To find x, multiply both sides by 3/2, so I get 9 pi over 8. So I multiply this equation by 3/2, both sides. The left hand side becomes x, right hand side becomes 9/8 plus 3k pi. The other possibility was 2x third is this one. It's 5 pi fourth plus 2k pi. To clean that up, also multiply by 3/2. So x becomes 15/8, and then plus 3k pi. Now, if k is 1, I already exceed my 2 pi range. If k is minus 1, if I subtract minus 3 pi from this, I'm going to get a negative quantity. So the only acceptable answer left for me is just when k is 0. So x is 9 pi 8. Here, if k is 0, I get one answer, which is 15 pi 8. If we add to it, we are going to exceed our range. If we subtract minus 3 pi, we are going to be a negative value, and then that is going to not be in the range that we want. So these are the two answers that are left for us. Here is cosecant. So we start with theta being 2x. Cosecant of theta plus 1 is equal to 0. So cosecant of theta is minus 1. We remember cosecant is 1 over sine. So sine of theta, find the reciprocal of both sides. Sine of theta has to be minus 1, which means that theta has to be 3 pi over 2, and then any multiple of pi, 2 pi can be added to it. Now we go back to the fact that theta is 2x, so 2x is 3 pi over 2 plus 2k pi, divide by 2, so this becomes 3 pi over 4 plus k pi. So of course, if I let k equal to 0, I get an answer that is acceptable, 3 pi over 4. it is in the range we want. If I add 1 pi to it, what do I get? I get 7 pi over 4. That is acceptable because 1 pi added to this, I get 7 pi over 4. That is less than 2 pi. If I add another pi, it becomes 11 pi over 4. That's exceeds. If k, I take it to be minus 1. If I add it to it, I get negative. So the only answers that are acceptable to me are just these two numbers. So we neither allow any answer that's below 0, nor any answer that at 2 pi or above. So another practice very similar to last time, and perhaps a couple of more variation on this theme, and then we are going to be out of this repetition. Until next time, good luck and God bless.